I only have like 2 pens, 3 pens. Does anyone want to borrow a colored pen for this? All right. So we're going to get started with today's notes. And so the first thing we're going to learn about is standard form. And right here you can see, remember, it's ax squared plus bx plus c. That means everything is on one side of the equation. And so there's certain times that we would use each of these equations. And so standard form is important because it gives us our y-intercept. So write that down. It gives us the y-intercept. So when we're looking for something like the y-intercept, like your initial value, your starting, the best form to use is standard because it gives you your y-intercept. What's your x-coordinate in your y-intercept? Anyone know? It's always the same. What's your x-coordinate when you're looking at your y-intercept? 0, right? And so we know our x-coordinate is always 0. If I were to plug 0 in here, anything times 0 is 0, plus anything times 0 is 0, and what's left over? C. C is always your y-intercept. So if you're looking for your y-intercept, it's 0, comma, whatever your constant is. Just like when we did our do now, you saw that the constant here said was -5. That was the one by itself. It's the same thing here. So standard form gives us the y-intercept pretty easily. Make sure you guys are writing this down. In the second one, it's vertex form, and they give you that right here, right? Vertex form, you can probably guess, gives us our vertex pretty easy. And so if it gives us our vertex, it also gives us our axis of symmetry. Who can raise their hand and tell me why would it give us our axis of symmetry if it gives us our vertex? What's the relationship between that? Anyone know? Why would I be able to get my axis of symmetry if I know my vertex? What coordinate's the same? Axis of symmetry. What coordinate's the same? The x coordinate of your vertex. So you know that the axis of symmetry is your x coordinate of your vertex. You also know that it could give us our min and max, which is our y coordinate of our vertex. Now this one's a little tricky because see how the h is in parentheses? You guys see that right here? See how it's minus h? Minus is the same thing as opposite. So basically what they're saying is the opposite of h is your x coordinate, and the k is your y coordinate. So that would be your vertex right there. And I'm going to show you examples so that makes a little bit of sense. So I'm going to give you 2 examples. The first one will look like this. X plus 3 squared minus 1. So write that example down. And so whatever is in parentheses is the opposite. So see how it says plus 3 right here? What's the opposite of a positive 3? Negative 3. So your x coordinate is actually negative 3. So usually in quadratics, if it's in parentheses, it's the opposite with these 2 forms. But if it's outside the parentheses like this, it's the same. So since this is -1, it'd still be -1. So your vertex here would be -3, comma -1. So it easily gives you your vertex. Does that make sense? So if I had something like this, y equals 3x minus 2 minus 3. What would my axis of symmetry be for this one? You can raise your hand and tell me, what would my axis of symmetry be for that second one? remember it's the opposite. So what's the opposite of -2? +2. So your axis of symmetry would actually be x equals 2. Your vertex, Gabriel, was what? I heard you say it. 2, -30. So you guys see that inside, it's telling you it's the opposite of whatever that is. So if it's -2, you know it's a +2. If it's positive, you know it's a negative. No, only what's in the parentheses. Whatever's outside the parentheses is the same. Does that make sense? Okay. Last one. And I'll scroll down as I'm doing it. So the last one is factored form. You can see that these two equations, even on your milestone, on your final that's coming up in a few weeks, everything, all these formulas are given to you. So you can see how it says -h right there? That means opposite. So it reminds you, hey, it's the opposite of whatever that number is. So if it's positive, it's negative. If it's negative, it's positive. Same thing with factored form. And so some of us took Algebra 1 before, and we multiplied polynomials. We didn't do that yet. And it was on your midterm, but I didn't count it against you guys. But we are going to be learning that next unit. But you know, if we do the FOIL or box method, however you did it in the past, or if you did it, that it will end up being an x squared. And so this is factored form, and this is important because it gives us our roots. Who can raise their hand and tell me what does roots mean? X what? Intercepts. So our roots, x-intercepts. What's another word? 2 more words that mean x-intercepts. Starts with a Z. Zeros. And the last one starts with an X. O. L. U. C. Solution. So if they say any of those words, factored form is our friend because that means it's easier to get. And so your x-intercepts are the opposite of the number right here. So see how it's in parentheses and there's a minus? It's whatever the opposite is of each one. So it looks like that. Because you know, usually you have 2 x-intercepts, sometimes you have 1, but usually you have 2. So I'll give you an example of this one too. So if you have y equals 3 parentheses x minus 3 x plus 2. That would be in factored form. And so to get your x-intercepts, you know that it's just the opposite of whatever's in the parentheses. See, like that this was the opposite also, and it's still your x coordinate. So right here, what is the opposite of -3? +3, right? So it'd be 3, 0, because remember your y is 0 during your x-intercepts. And what's the opposite of +2? -2. Oh, comma 0. The last thing before we practice for today are our A's. So our A, and I'm just going to put it right here because I have room. Our A is our leading coefficient. So remember we talked about leading coefficient as positive Patricia and negative Nancy? Remember that? So all the A's here, so this one right here, this number, and this one, they're all your A's. They're telling you the direction it's facing. So if that A is positive, we know it's going to be a positive Patricia, and it's going to look like that, where it's concaving up. If it's a negative Nancy, we know it's concaving down. Now, if it's a positive Patricia, we know it's concaving up. Does it have a min or a max? A min, right? Right here, because it's your smallest point. So we know if that A is positive, I'm going to have a minimum. If negative Nancy, she's pointing down, she's going to have a max. It's going to be her top one. And so that's with all 3 of them. So whatever's in front tells you the direction that it's going in. So I'm going to do a few more examples with you. I'm going to look at this paper right here. I don't have it on my board, so I'm going to handwrite it. But we're going to go over a few on there and then play our computer game. That's it. That's all you're learning. So get out this paper with the weird black on it. And we're going to look at these examples. So the first one looks like this. So first thing says, what is given? Who can raise their hand and tell me, first of all, what form is that in? Raising your hand, what form is this first one in? Vertex form, right? Because you can see it looks like that vertex form that they give us. So first, where it says form, you're going to write vertex form at the top right here. Vertex form. In vertex form, what's given in vertex form? The x. X of what? So it's the A. What do we call that? Leading coefficient. We are given leading coefficient. We're also given the axis of symmetry, which is your x coordinate of your vertex. And also what else? Not solution. Look at your paper. In vertex form, what does it give us? Min, max. And lastly, the vertex, right? Oh, for which one? Yeah. So direction it's facing. In front of there, if there's no number, what's the invisible number? 1, right? And see how this 1 right here is positive? It would be a positive Patricia, so it would be concaving up or concaving down? Up, right? So because it's positive Patricia, we know she's concaving up. Would positive Patricia have a min or a max? A min, right? And the min is your y coordinate of your vertex. So Christopher, what is the y coordinate of our vertex? What is our min?
Oh, -9.
Yeah. Y equals -9. Because right here is your y coordinate of your vertex. So that means when I'm looking at this graph, the very bottom of it is -9. What is our vertex here? We know if it's in the parentheses, is it the same or the opposite? Opposite, right? So we know this is now going to be -2, and our y coordinate is going to be -9 because that's the same. So that's our vertex. So it would look something like this: -2, 2, 3, 4, 5, 6, 7, 8, 9. And it would look something like this. So our axis of symmetry is our x coordinate of our vertex. So we would write that as x equals what number? -2. Lastly, on your Kahoot, we're going to be talking about domain and range. Does anyone for a brain bug remember domain of all quadratic functions? It's the same thing. Maybe look through your notes. What's the domain of all quadratic functions? It's in that blue sheet. Not 0. It looks like this. It's something comma something. But it's not a. Who said that? Siri, you said that? Negative infinity to positive infinity, because they're going both directions forever and ever and ever. Good job. So that would be your domain, because it's going side to side forever and ever. Your range, we always go bottom to top. And so when we're looking at the bottom, the minimum, what's the smallest y value here? -9, right? So we would start with -9 and it's touching, so it would be a bracket. And see how it's going up forever and ever and ever? That would be infinity. So that would be my range. Does that make sense? Okay. So you guys are gonna log on to Kahoot. We're gonna go over this. But see, while you're logging on, try the next two columns. We'll go over them. But I want to give you time to log into Kahoot so you're all set up, and we'll go over the last two together.